I think we are live now, so I can start. Um, I'm basically going to take 20 minutes, 15 minutes to talk about Hyperlane's open interoperability framework. So, if you know about Hyperlane, this will be like a refresher. If you don't know anything about Hyperlane or interoperability, that's also not a problem because we will be covering like a from it ground up. So I think it should be fine for anyone with any knowledge of um, the blockchain world. So for a quick introduction, my name is Eda, and I am part of the team at Hyperlane. I work as a developer advocate, so I think this is my third ETHGlobal event with the team. And today, what I'm going to be doing is giving an overview of the blockchain interoperability ecosystem, and then I'm going to be talking about specifically what you can do with Hyperlane, what tools you can build out, and then I will also go over like the bounties we have, so then you can have like a good idea for what you can build for the hackathon. Does anyone here know about Hyperlane already, or okay, we have a small audience, but I think it's live streamed, so maybe there are more people watching or will watch afterwards. But I do want to give a quick introduction. So, when you think about interoperability, what I usually think about is I go to DeFi Llama and I see like there is a whole spread of chains that you can build on today. And the question becomes okay, like we live in a multi chain world, but which chain do you choose? Which chain do you work with? Um, and not only are there like multiple chains, but there are multiple roll up as a service platforms where you can easily spin up your own chain too. So when there's like a very segmented ecosystem, what you need is like some kind of glue in between, which allows you to talk with different chains. So then you are not like just in your own ecosystem. And yeah, what does like this sparse ecosystem mean for users? Well, it definitely means that interoperability between rollups is sparse and highly fragmented. So this means like you have assets living on one chain but not on the other. You have a lot of user friction when you need to like change between wallets. You have a lot of disconnected applications. So if you want to build an application on Base, then that usually like lives on Base itself and doesn't connect to like, the other chains. And when I look specifically at Ethereum, what this means is that when I'm transacting with Ethereum is that I'm switching between networks. So it doesn't really give a best, like the greatest user experience when you want to build an application that lives across multiple chains. Like as you can see here, like this wallet is connected to like 7 networks, and whenever you're on which network, you have to switch. So that's kind of like not the best user experience, especially when you think about like your own Web2 banking application, which is super easy. You have like PayPal or like other applications which allow you to transact super easily. And the goal with all the interoperability efforts is to make Ethereum feel like a single chain again. So what we're trying to do is we're trying to provide the tools and infrastructure so that you can like do all the interactions on a single chain, and then that will like carry the interactions on the back end to the other chain. So that you don't need to worry about like which chain you're on as a user, or as a developer as well. If you have like all the tools to easily connect to the other chains, then that means you can build like cross-chain applications without being limited to a single environment. And that is exactly where interoperability comes in. So, what we are trying to do with interoperability as Hyperlane, and as you will see, like with other interoperability players, is that we are trying to make it so that you have all the tools, and not just tools, but you also need like more infrastructure, so then you can have like a connected blockchain ecosystem. And I'm actually not only talking like specifically Ethereum as well, but this means you can connect to like Solana or like Cosmos or other ecosystems as well. And that is exactly where a great segue into Hyperlane. So what we're doing at Hyperlane is we are building infrastructure for interoperability. So tooling and infrastructure to allow you to send messages cross chains. And the biggest use case of that today is asset bridging. And I will get to a bit more details on like the stuff we are building. So then that will be helpful for your hackathon projects, I hope. And also introduce the bounties we have. So then maybe you can like build through them. I know when I was a hacker that was the most like interesting part to me when I came to talks. But I do want to give a quick overview. So Hyperlane is a permissionless interoperability protocol for cross-chain communication with modular security. That is a mouthful, but I will break down every single point over here. So what I mean by um, what I mean by permissionless interoperability protocol is that Hyperlane is fully open source. You can deploy it to a chain that it's not already on, by free of charge. You don't need to do anything. You don't need to come to us. You don't need to talk to us. But what this means is if you do it yourself, you do need to run your own agents. So I guess the value add of like Abacus Works, which is the team behind, is to allow you to like run all the agents by selves. But for the purpose of the hackathon, like let's say you're working with a chain that doesn't have a Hyperlane deployment, you are free to go ahead and do a Hyperlane deployment, all open source. We have the guides to set up on a new chain. That means you also have to need to run your own agents, which we will get to in a bit as well. And then cross-chain communication, I think we covered that quite a bit, is you have one chain, you have another chain, and you want to like send messages between them. As I mentioned, the biggest use case is asset transfer, but it can be more like general, like any kind of message can be sent between chains. And then modular security is like most people, especially once they get into interoperability, they come to ask, they're like, okay, but how is this like bridge secured? Like if I send a message, does this actually come from this sender? Or like, how do I know that the message was actually like untampered and reaching my new chain? That is exactly where the modular security, which we call ISMs, interchain security modules, comes in. So you have different building blocks for ISMs, and I will get to that in a bit as well. But yeah, so we talked about interoperability on any chain or rollup. It's permissionless. You can go ahead and deploy it yourself. Today, if you want to see the chains that Hyperlane is already deployed on, you can go to the Hyperlane registry. Hyperlane is on over 150 chains as of today, and you can go over there to see the exact number and what chains it is deployed on. You will also see like the mailbox configurations. So if you want to connect to one chain, you will need that like contract addresses over there to see which address you need to talk to. Modular security, we will talk about it in a bit as well, but basically we do have a default security setting which uses the multi-sig ISM module, but you are you are able to extend that security module or build out new security modules for the hackathon as well, for example. And simplified cross-chain communication. A lot of people want to communicate cross-chain, and if a lot of people like do it from ground zero, that will take so much time and replicated efforts. So what we do is we provide those building blocks, so then not everyone has to build it from like ground zero. And this includes like our TypeScript SDK if you want to talk with like different Hyperlane infrastructure components, as well as the agent infrastructure that we are running. Modular security. So I touched on this a bit, but the way security works in Hyperlane is that we have these like Lego blocks which you can choose from that are called interchain security modules, ISMs. By default, most warp routes today use the multi-sig ISM, but I think actually like building a ISM module is a great hackathon project if anyone is interested in that. And well, the default ISM, which is the multi-sig ISM, as the name implies, it basically checks like for signatures. So it's usually like a 2 out of 3 configuration or any kind of configuration you set. But you can be like, hey, I actually want to use like ZK proofs for this. How can I do that? So that's where you can go in and you can build your own ISM module and kind of submit it as a project. And the architecture. So I mentioned mailbox, I mentioned like relayer, I mentioned like validators. How does this actually fit in? And what can I build with it is probably like the question like most people think. So to talk a bit about the Hyperlane architecture overview is basically the origin and destination. Think 2 chains. Let's say like Base and Ethereum mainnet, just like for making it a bit more concrete. You have the mailbox contract deployed on these on these chains. Basically, mailbox is like your interface into a new chain. When I said like we are on over 150 chains, that means that we have like a core Hyperlane deployment, which includes like the mailbox contracts and like the extra ISM settings for that chain. So once the mailbox is deployed and the other core contracts are deployed, that means that all other Hyperlane connected chains can talk to them. And this is done by a standard mailbox contract. So yeah, the mailbox is, I guess you can see it over here as well. Like the sender sends a message to the mailbox. And then likewise, when you look at the destination, the message is first received at the mailbox. Like your interface into a new chain is via a mailbox. And then, so when a message arrives to the mailbox, what comes into play is the relayer. The relayer is like an off-chain agent which carries a message from one chain to another. Now, it doesn't do like any security checks. That's where the ISM, the interchain security model, which you see over there, comes in. But the relayer is like a off-chain agent, which takes a message and delivers to the other side. And then once the message is delivered, then what the destination does is destination verifies that the message was actually coming from that sender. And that is done via the interchain security module. By default, as I said, like if you look into like a multi-sig ISM over here, that would mean you also have like some validators running in between that attest like, hey, okay, like this message was from here, like send a signature. And when you get like a 2 out of 3, that's like valid. So then it reaches the recipient. But yeah, this is like, I think, a good overview of how the Hyperlane architecture looks like. You have core contracts that are deployed. Most important, I guess, is the mailbox contract. If you have a mailbox and like all the extra gas like how you pay the relayer, etc., the contracts we call as IGP, then you can talk with multiple chains. And yeah, what we provide is actually like not just this architecture, but we want to make it easy for people to build. So we have some tools which you can directly leverage without being like, hey, I don't want to actually like build any infrastructure components. What can I do? Do you have an SDK? You can directly use our TypeScript SDK. And okay, so I want to talk a bit about the applications, right? Like I mentioned the overview, but like what does this actually mean? What can I do out of the box by like just easier? And I guess the main one is Hyperlane warp routes. So Hyperlane warp routes are leveraging the Hyperlane infrastructure that I just talked about for asset transfers. So when you look today, the most like used application for cross-chain communication is asset transfers. And Hyperlane warp routes are basically like a collection of contracts that make it easy to do that. So when you deploy this architecture, this doesn't include like the core ERC20 contracts or like standard token contracts where you want to build a bridge, like a mint and lock bridge from one end to another. But that is exactly where Hyperlane warp routes comes in, is that they are standard deployments that support various assets, most notably like ERC20s, for you to transfer assets between chains. We recently, not that recent, but like been 3 months or so, launched Hyperlane warp routes 2.0, which also do native rebalancing. So let's say like you make a Hyperlane warp route between Base and Arbitrum, but now you want to add one more chain. So you're like, I want Base, I want Arbitrum, and then I want like Optimism, OP mainnets. And then you want, like, you have collateral on all these chains and you want to natively balance it. That's exactly where Hyperlane warp routes 2.0 come in, that they have like a rebalancer agent which rebalances the collateral between these chains. A cool project is that we currently do rebalancing for USDC ONI using CCTP v2. So if you are like, hey, like I want to build like rebalancing on other assets or other chains, that would be actually like a cool hackathon project, which I've been telling to people coming to the booth as well. But yeah, you can totally like build an architecture which does like rebalancing for Hyperlane warp routes 2.0 because that's currently not something that exists. And then Hyperlane warp route types. Yeah, you can have like native tokens, collateral backed tokens. I'm not gonna like go into detail, but you can basically, if you want to do like a native token Hyperlane warp route or a collateral like a USDC token, you can do that. You can have like a version where you have a collateral on one chain and then you mint a synthetic, like create the synthetic representation on another chain. So there are different types of Hyperlane warp routes that you can leverage. When I said USDC, like it's usually on most of the chains already. So that's like a collateral to collateral transfer. But let's say like you have a new chain, like I make a new chain called Spaceship Chain, and then that Spaceship Chain doesn't have, you know, a native asset from like doesn't have ETH already. So I can create like a synthetic representation of that spaceship chain, or like I can create like a new asset there. That is exactly what synthetic ERC20 is referred to. And then, yeah, there's also, actually also like, I didn't think of this before, but now that I'm looking into the slide, there's also specialized Hyperlane warp routes, which one of them, we have 5 minutes left, I'm getting the warning. We have yield routes as well. So when you want to like transfer assets directly into a vault, so that is like yield routes, you can build an architecture which extends the current yield routes we have to like multiple deposits or like multiple yields. This was something I did not think of before, but would be a great hackathon project too. And then I'm going to move fast because apparently I have 5 minutes left. but this is a simplified Hyperlane Warprout contract flow. The difference you see over here is that you see like there's the EVM hype collateral, and then there's also the EVM hype synthetic, which is just like examples of the ERC20 contracts which we deploy for making this asset transfer work. So it just like adds like a few more contracts than what you had in the original architecture to make it easier, since like most people use asset transfers. Let's make asset transfers easier with the architecture we have. So that's kind of Hyperlane Warpouts. Another feature you can use or application of Hyperlane is interchain accounts. These are interchain accounts basically enable a contract on one chain to interact with any contract on another chain. So when we want to make like changes to like basically, let's say you have like a Hyperlane warp route and you want to extend it to multiple chains. So if you have like if you want to directly make it from an interchain account, that will make it easier because you can just like make that contract interact with all the other contracts on the other chains instead of doing that one by one. So interchain accounts are a cool feature which you can use. I think it would be pretty cool to like build a hackathon project with them too. Yeah, like they're something which are more new and more used internally. So it would definitely be a good use case to work with interchain accounts. And then ISM, I mentioned quite a bit. This is the security modules. I'm not going to spend more time here since I don't have much time. Case study, we have like a few case studies on the documentation. You can have a look. Veldrum Superstops is a really good one because it uses interchain accounts, Hyperlane warp routes, and OpenUSDT, which is like a stable coin for the superchain ecosystem. But yeah, you can have a look to see how like the architecture leverages Hyperlane for swapping, because I mostly talked about bridging, but what Veldrum does is they do like swapping with Hyperlane's infrastructure. And then ETHGlobal, what do we have right now? We have 10K in bounties for 3 categories. I'm going to go to the categories. We will be at the booth all weekend. I think like from 1 a.m. to 7 a.m. there might be like online Discord support, so you can join the developers channel for that. We have quite a bit of people from the engineering team, so you can come to us for debugging, for like idea help, any kind of questions you have. We will mostly be at the booth. I'm not exactly sure how to explain where the booth is, but you can walk around and find us somehow. And then our bounties, 10K in bounties across 3 categories: best use of Hyperlane, best infrastructure, best interchain app. The best interchain app, self-explanatory, an application that is interchain. Best infrastructure, maybe something with the rebalancer, with the agents, with the ISMs. Best use of Hyperlane, it's again more general. For example, you can also use the TypeScript SDK if you want to like use Hyperlane in your dApp, or if you want to like build an infrastructure component, that would also be cool. Yeah, these are the 3 categories we have. If you want deeper questions, you can definitely come to the booth. Basically, any project that leverages Hyperlane in a meaningful way will qualify for a prize. And we are hiring. So we're hiring for a senior protocol engineer and a senior Rust engineer. So if you are interested, we would love to talk to you at the booth as well. Just want to call out that we are hiring for 2 roles. And yeah, we're mostly looking for people with New York or London preference, but also like looking for remote. But yeah, and that's all from me. I have 2 minutes left. Happy to answer any questions. You can scan the link for our documentation. Yeah, and you can find me at the booth with other people there as well. And yeah, thanks for coming. If there are any questions, happy to answer them. If not, maybe it will take some time to process the information and you can come later and I can answer them later on too. How hard is it to write the security module? I mean, that really depends on what kind of security module you want to write and what kind of skill set you already have. Like if you want to write a ZK security module, you can do that if you have like already expertise in ZK. But if you don't have any experience with ZK, then that might be pretty hard to do so. But yeah, it really depends on like how much experience you have in a certain field that you want to write it. You can actually like look into our documentation to see examples, because they also vary a lot. Like there's like an off-chain, it's called like off-chain ISM, which verifies information that was off-chain to make sure that it's correct as well. So there's quite a few things you can do with security modules, and yeah, so I wouldn't say. Like for me to write a ZK ISM would definitely take a long time, but if you are confident with it, you can definitely do it much faster. I think that's all for questions. I guess we can, yeah, I guess that's all from me today. Thanks, guys.